Let's take a look at domain and range of exponential functions. Remember what an exponential function looks like. Exponential functions look like this. Y equals a times b to the x plus p plus q. Using these variables, we're able to determine what the domain and what the range will be. The function is defined for all real numbers x. Since x goes with our domain will always be all real numbers. Now let's look at our y. Our y is first determined whether or not a is a positive or a is a negative number. If a is positive, then our range will be y is greater than our q. If our a is negative, our range will be y is less than our q. Our q is what determines our horizontal asymptote. And the reason we are greater than or less than and not including the equal or not including the q is because we remember our graphs approach our horizontal asymptote but do not actually touch it. So we cannot include that when discussing our range. Let's take a look at some examples. Here's our first example in yellow. Y equals 2 times 3 to the x. Well, let's take a look at what we need to know. Our a. Our a is which value? Our a equals 2, which means that it's greater than 0. So we should be using this y greater than q for our range. What is our q? Notice that our q comes after our b to whatever exponent. In this case, we don't have anything there, so it is plus 0. So our q equals 0. Our domain is all real numbers, and our range is y is greater than our q, which in this case is 0. Let's take a look at our next example here in red. Y equals negative 2 times 1/2 to the x. Again, we need to first identify our a. Our a in this case equals negative 2, which means it's less than 0. So our domain is going to be y is less than whatever our q is. Just like our example in yellow, we don't have a plus number, and that it is plus 0, and our q is 0. So again, our domain is all real numbers, and our range is going to be y is less than our q, which is 0. Let's take a look at this example. Y equals 2 to the x plus 4. Remember, we need to first identify what our a is. In this case, we have b to the x. B is our 2, but we don't have anything here in front of the 2. So what goes here if there's nothing written in our problem? Well, of course, that means that there's a 1. So our a, in this case, is 1, which means that it is greater than 0, and we're going to have a y is greater than whatever our q is. Well, so we need to identify our q. What comes after our b to the x? Plus 4. So our q is 4. Again, our domain is all real numbers. Our range is y is greater than, because our a is above 0, y is greater than our q, which is 4. Now let's take a look at this graph. We don't have the function written, so we just need to look at what our graph is actually saying. Again, our domain is with our x's. So as we can see, our graph would keep going on forever, which means, so our domain will include all negative x's. And now we take a look at the positive side and see that it keeps going forever. And we can say the same thing that all positive x's. We again agree that the domain will be x is all real numbers. So now let's look at our range. We can tell here that we're going to be positive something based on the graph. So let's draw in our asymptote. Here in green, I have drawn the horizontal asymptote. It is at y equals 2. Now we notice that our graph never goes below that line, but it also, as we know from the definition of an asymptote, never touches the line. So since everything else in our y is included, we know that our range is y is greater than